Topic yesterday. I had a conference presentation yesterday morning, and since I don't want you guys miss the class today, so I came back early yesterday afternoon. Later on, then come to school this morning. It's so cold. Right? I drive to Myrtle Beach on Wednesday after the class, and I come back. A presentation yesterday morning, and then come back yesterday afternoon to Fayetteville. Here we go. Right. But anyway, I will have a rest also in this weekend. First, I have graded your midterm exam. As I have mentioned, I won't return to you personally, but you can come to my office. We can review exam together. If you have some concern about your grading, you guys check your grading? Everybody, right? So the medium score of this midterm exam is 76. So which means, okay, if you get 76, that's like in the middle of this class, just for exam 1, 76. Yeah, but we do have one student gets 100 points. So, well, 76 is very low. I can tell you based on my experience for teaching so many semesters. For the first exam, medium score 76, the normal of the normal, very normal. So, you can perform better next time, yes. Yeah, but you need to concentrate, work hard, and especially when we go through the example in class, you don't want to miss that. Okay, so and also I posted bonus points for attending last Wednesday's presentation. If you didn't get bonus points, you think you deserve to get, let me know. So Wednesday's class we have talked about to build a control chart to control our variable, such as mean, such as range. We have discussed why we need both of them. Mean, understandable, right? Because we want to control the average performance of our product, of our service, waiting time, average complaints, blah blah. So mean control chart is widely used. Ranging control charts, I give example here. If you want to purchase a new car, miles per gallon, average miles per gallon is important, but also the variance of the car you get is also important. So that's the reason sometimes we also need the range. How do you build a control charts? Okay, so you need to first calculate the grand mean, which is the average of the sample mean. So just remember here, this K is the number of sample. Sample size, the notation of sample size is N. We'll see that. And similarly, R bar equal to summation R. And then if we know the standard deviation of the sample distribution, then we can calculate sigma x bar equal to sigma divided by square root of n. Again, what does this n mean? Represent small n. What is this? Sample size. Good. Okay lah. The sample size is small n. So always keep that in mind. N is sample size. K is how many samples. Right? Each sample has sample size equal to n. And you may take like 10 samples. Each sample include 100 data points. That means n equal to 100, k equal to 10, right? Because in the example we will get very soon, some students may confuse about n and k. And then you can build the control charts. UCL is equal to x double bar plus z alpha x bar, sigma x bar. LCL x double bar minus z sigma x bar. That's the case when we know the standard deviation, when we know the sigma, right? We can plug it into this formula to calculate the standard deviation of distribution of the sample mean. If we don't know, okay, that's become pretty straightforward. Okay. Upper control limit is x double bar plus A2, which is the factor, we'll see a table very soon, times the range, the mean of range R bar. Similarly, lower control limits, grand mean x double bar minus A2 times R bar. To build a control charts for range, so UCL range equal to D4 R bar UC over LCL range D3 R bar. Okay. How do you guys D1 A2 D3 D4? Here we go. Given the sample size in this table, if you have textbook, you will also find that in your textbook. Given the sample size, for example, if the sample size is 5, the A2 is 0.58, D3 is 0, D4 is 2.11. It's in your textbook, right? So you can guess that. Okay, now let's do this example together. So an inspector took 5 samples. 5 samples. Okay. Each with 4 observations, which means n equal to 4. Right? N equal to 4. Right? 5 samples, you should know what does this 5 mean. Which notation represents 5? K. That's right. It means K. K is how many samples we have. We have 5 samples. So K equal to 5, N equal to 4. Don't make it confusing, right? Observation of the length of the time for glue to dry in minutes. From previous experience, the standard deviation of this process. What is the process? The standard deviation of the process. What is the process?
Glue drying. Glue to dry.
Glue to dry, right? When you put the glue on the surface until it's dry. So that's process. From experience, it's 0.02 minutes, the standard deviation. Okay, then we know sigma, which is the standard deviation of the process equal to 0.02 minutes. Then you know that's which formula you should go to build the control chart, right? The goal is to obtain a 3 sigma control limits for means of future time. So you can see we have introduced how to calculate x double bar, how to calculate sigma x bar. We didn't talk too much about z value here. Z value is how times you want to control your quantity. For this example, what is z value? 3, right? 3 sigma. So you can see that's sigma, right? How many sigma? 3 sigma. So that means you want to times 3 by the sigma x bar. Okay. That's your goal. I think the formula is very clear here. Right? That's the formula you should use for the mean chart. Give you guys 10 minutes should be enough, hopefully. You have to follow the step. You calculate the grand mean, calculate sigma x bar, and then plug in to these 2 formula, get the control chart. So we have 5 samples. Each sample has 4 observations, which means if we want to focus on one sample, should we look at the number in a row or number in a column? One sample. So in a row or column? Column. Kayla has said. Because we have 1, 2, 3, 4, 5 samples. So each column corresponds to the observation for each sample. So if you calculate xi bar, here's xi bar. That's sample 1's mean. It's already calculated for you. The mean of sample 2, sample 3, sample 4, sample 5. And then pretty easy to get this square mean. And also, by the way, I have received 2 groups tell me the preference of the teammates. I'll try to find these requirements. If you still have some preference, let me know today, like by 2 a.m. I think that should talk with your classmates. If you have preference, send me an email. After 2 p.m., I will try to assign randomly for the students who didn't show any preference.
I did get her preference, right?
Yeah. You and who sent the email? Is that you?
I sent the email
Okay.
that it was gonna be Kate.
Yeah, I remember. As I have told you guys, it can be 4 or 5 people. So if you have 4, maybe I will add another student too.
Okay. You have figured it out.
Well,
Yeah, in this. Four observations. No, so K is, you said K was the number of samples. So there's 5 samples is K. The observations are 4. N equals 4.
K.
Then I'm gonna do the middle part. Let's see.
Yeah, so the last row, right, is the xi bar. So you guys together, that's 5 xi bar, right, for each sample. And then divided by 5, you will guess what it means.
Run it all down.
Like that test? Some textbook?
Textbook guides you in the right direction. Yes, but you get guides. Now I know. Yeah, that's right.
This was fantastic. By hard working I bet definitely believe hard working people, right? Otherwise it's
If you don't know
no idea. No feel? No idea.
it was a
So you should first figure out the grand mean.
definitive
X double bar.
it's given.
How to calculate X double bar?
It's not given. How do you?
Michael?
Just to double check, it's double bar is the sum of all the means.
That's right. That's right. Case number of You're very close already. Almost done. Good job. Sum of xi bar, you mean?
I don't think you really have as long.
So, look at the last row. Last row, they already calculate x I bar for you. Like first column is x1 bar, 12.10. Like second column, 12.11 is the x2 bar. Just add them together, divide by 5. It will give you the grand mean. Right?
I didn't want to be that one. That's why I wanted to keep my.
All stuck together. First, try to figure out the the grand mean, x double bar.
So that's adding on the grant, you'll be X on
Yes.
If I love you.
My
That's
calculator
like,
back.
if I'm extra late.
That's great. And then next step is to calculate sigma x bar.
5 minutes.
Yeah, the standing deviation. But what is sigma? Sigma is already given.
By the
0.03
time I parked, it's 10:07. So I left out in the minutes at 10:08 by the time I got the car. 10:08.
So you guys.
Yeah. The last step.
So what on the X double bar, the very first one, you gotta figure that one out
There's
first,
more
right?
general.
Yeah, it's like the mean of all the mean.
Yeah, I got my contacts in.
So you,
I think it was at what,
Who am I
at one
contacting?
point.
that whole row, I mean the column, I mean,
Well, I just did the row. I mean, like, is that all they need?
That right?
row, so row one is 12.11, 12.15.
No, it's like the last row where the bars are. That's all it's together.
Then this is your control
Oh,
chart.
okay.
So that means in the future, okay, next day, if you like test another sample, like choose 4 observation, if the mean is beyond this range, that's you need to modify what's wrong.
Is that the X double
For example, take too long, 12.2 minutes, 12.2 for the group to dry. Okay, and it's wrong. So you use this control chart to monitor your performance in the future. So that's the purpose. And once you get this control chart, you can control your quality. That's the standard, right? When you talk about quality control, you need to have standard. That's just the standard.
Maybe that's the first motorcycle. What was I showing you yesterday? I was showing you
That's grand.
I was showing you the class.
Pass.
Honestly,
Can you give me a motorcycle?
I showed you the class.
Nah, I don't drive.
They had nobody like
Okay, so I have seen some students already finished these questions. Some students are still in the middle of the process. We can do that together. First, we need to figure out grand mean, x double bar. Which should be the easy part. Any volunteer to tell us how to get the x double bar? Anybody?
You add up all the x bar and divide by 5.
Yeah. So what is the x1 bar?
Oh, 12.1.
12.10 plus 12.12. 0.11 plus 12.10 plus 12.12 divided by 5. What is the mean then? 12.11, right? So that's the grand mean, x double bar. So next step, what is the next step after we get the grand mean?
Find the UCL and LCL.
Directly? That's something we need to calculate first.
Yeah, you have
The mean, oh, I mean, it's fake.
The standard deviation of the sample distribution, right? X sigma x bar. You have to calculate for this first. How to calculate this? What is sigma?
0.02.
0.02 is already given from the question, right? Standard deviation process 0.02. What is the n?
4.
4. Because n is the sample size. So it's pretty straightforward. We get 0.01, which is sigma x bar. And then next will be pretty straightforward. We just plot these numbers we get, x double bar, 12.11 plus, what is the z value?
3.
3 times 0.01. Lower control limit x double bar, which is 12.11. Minus 3 times 0.01. So upper control limit is 12.14, lower control limit 12.08. So that means we get this control chart from 12.08 minutes to 12.14 minutes. Anything follow between this range, we assume is normal. Well, we can make the type 2 error. Okay, always remember, okay, even we say we think it's normal, maybe it's already out of control because the sample. But we can assume it's normal. We don't need to spend time to dig out. But anything beyond this range, we think is abnormal. Then we need to dig out where some problem, or maybe not problem, because type 1 error. So that's how we use the control chart. For example, tomorrow, you choose another 4 samples. Those 4 samples. You choose another sample with 4 data points. And then you calculate the mean, the average time for these 4 groups to dry tomorrow. If it's 12.2, do you think it's under control or out of control? If the mean time to dry, out of control, right? Because it's ready. Similarly, if we only 12 minutes, do you think it's under control or out of control? Only 12 minutes. 12.0.
Oh, it's
Yeah, it's also control too, right? Maybe you want to dig out. For example, usually company were like, okay, the time for the glue to dry as short as possible, right? But if you got 12 minutes is out of control, you should dig out. Okay, why today our glue dry? Okay, cost less time. And maybe you can learn the lesson, improve our process. It can be a good benefit. But say for higher, definitely should raise concern too, right? So clear? How do you use this control charts to monitor our quality? Clear? Yeah. So when we talk about quality, okay, you probably heard about that. You guys are most senior students, heard about it in different class, quality. But I believe this class, probably one of the leading class, tell you, okay, what does quality really mean? We need to have measurements. This is the statistics. To build these measurements based on our historical data, then you use these control charts to monitor your quality. That's the scientific management, right? Okay, so next extension of this example is that we also want to control the range of our performance. We don't want one glue dry in like 11 minutes, another glue dry in 13 minutes. That's not good either, right? So we want to build a range chart and use these range charts to control our future performance. But we know that for the ranging charts, we need to use these two formulas, right? Okay, R bar is the R bar is just the grand mean, grand mean of the R. But first we need to figure out D3 and D4. Let's come back to this table. Anybody can tell us how to find D3? What is the value of D3?
0?
0. Rings. First, the ice is sharp, right? It's pretty tiny, right? So how do you guess 0?
Well, I just went to number 3 in the end.
3?
Yeah, and then just.
Why is 3?
I don't know, it's just you said D3, so. I don't know, I'm sorry.
5.
5?
Is that right?
No.
Did you do that in that one?
You shouldn't look at the row of 5. Which row you should look at?
You should look at 4.
4. The sample size is 4. Also remember this is the n, right? This is sample size. We know we already figured out sample size is 4. So we just look at this row. 0.73 is A2, which we don't use. This is for mean charts. 0, D3, and 2.28 D4. So we know that, okay. In this example, with n equal to 4, D3 equal to 0, D4 equal to 2.28. Now you know how to use this table to find D3, D4, and A2, right? Okay, then it's your job to build this control charts for range. That's all the things you need to know in this part. You need to look at the rest parts of this whiteboard. That's all the things you need to look at. But first, to calculate the mean of the range, you need to calculate the range for each sample. How to calculate the range for each sample? For example, the sample 1, we have 4 data points. 12.11, 12.10, 12.11, 12.08. For this first sample, 4 observation, what is the range?
You subtract. Is it 0.03?
0.03. You are right. Is the maximal 12.11 minus the minimal 12.08. So for the first sample is 0.03. We do the same thing for 5 samples, and you take the average, you get R bar. Right?
Oh, this is all these added up.
Okay, okay. You haven't divided by.
Oh, wait a minute.
Five. Yes, divided by five. Average. Okay, so that's a summation. We need to calculate the average.
Okay.
We're up to
R bar, how do you calculate? How do you calculate?
so you take tries.
You have to add.
I don't remember my mind.
Yes.
Oh, well, I think he got that from that other chart.
I don't think so.
Oh, I don't really like coffee like that. I mean, I don't
Okay, so that's probably something to calculate the range.
I shower.
Second is 0.05, what was the third one? 1.06. Fourth one is
But technically,
4, right? Last one is
I just
5.
have that.
Right.
That's right.
Do you multiply D3 times the average range?
Yes.
So that could be right?
Yeah.
Okay.
What do you think about the range? Usually the smaller the better, so it's not surprising.
Did you define that?
The lower bound is 0.
I mean, yeah.
It's not bad if you think about the range is tiny. It should be under
So we're
control,
right.
right?
We're right. Just don't worry.
So that's all.
That's you have to move further. Build this chart. Done? That's just how about it. What is the range?
You don't have A2.
You sound sick.
No, this is range charts.
You gotta use the orange to stug it out.
What?
I got the range of all those.
Okay.
Added them up.
For the R bar.
Yeah, R bar.
You have to go back to the chart.
Lower control limit.
Well, they have
The formula right, right? UCLR, LCLR, lower control limit.
That's why you see me drink.
The lower.
I never go to it. I always get like an 83.
Yeah.
I always have to do like 2 of those big Foster cans if you've ever seen those. What is D3 and D4? That's the only thing I don't understand.
Because you go to restaurant, maybe when I would explain that. Yeah, so
Okay,
that's the
got it.
table.
Got it.
It's the table, right? Everything here is pretty small. You find a sample size is 4, you get D3, D4.
I really don't.
I'm asking y'all what D3 and D4 are.
You got .0.
Okay.
Yeah, that's right.
So first, to build the range chart, we need to calculate the mean of range. Okay. Then we need to figure out for each sample what is the range. For sample 1, we have done this together. It's 0.03 minutes, the range, right? Sample 2, what is the range? 0.05. Because maximal 12.15, minimal 12.10, so 0.05. Sample 3 is 0.06. Sample 4 is 0.04 is the range. Last sample is 0.05 range. So we add them together, divided by 5, you should get the mean of range. What is the value you guess?
0.046.
0.046. Great. Okay, then after we guess this, it's pretty straightforward. Can remove this first. Upper control limit is equal to D4, which is 2.28 from our table, times 0.048. What is the result you get for the upper control limit? 0.1 0
Just put
8
5.
5, right? Okay. Lower control limit, because this 3 is 0, so whatever is times 0 is 0. So you guess the range control charge is 0 to 0.105. How to use this chart? Next day, you take another sample with 4 groups. Okay, then you test how long it takes each group to dry. You calculate the range. Okay, maybe what is the range for these 4 groups? If the range is below 0.105, then you think it's under control. But if the range next day you take the sample is 0.0, you think something wrong. Even maybe the mean chart we have built is follow the mean chart, but still the range chart can tell you okay dispersion is too high. Then we need to dig out okay what's wrong with that. But again and again, I also remind you guys, maybe you dig out there's nothing wrong. That's a type 1 error because we use statistics, right? Keep that in mind. That's very tiny probability. That's nothing wrong. But definitely anything beyond the charts, we should spend some time to find out the root cause or find out nothing wrong. Alright. It's clear how to use the charts, mean charts, range charts? Questions, comments? No? Everybody's good? Okay. So we'll show why we need both these 2 charts to control our quantity. Well, you can see for this, like say products A, we have the sample distribution is normal distribution, the mean is higher and higher. Finally, the mean is out of control. Then the mean charts, for this example, can discover the problem for us. Okay, we'll see, oh, that is out of control after 4 period. Well, on the other hand, the range charts can't tell us anything wrong, because the range is pretty stable, it's under control. On the other hand, for the products B, the mean is very stable, but the dispersion become larger and larger for each sample each day, right? And then we can't tell anything wrong from the mean control charts. Nothing wrong. Every dot is falling in this range. But if we build these R charts, range charts, we can tell, okay, in one point, the dispersion is too high, then it's out of control for range. Both of these 2 processes have something wrong. Agree? Right? Both these 2 processes. Well, this one is higher, keep increasing. This is higher and higher dispersion. But as you can see, that's the reason we need 2 charts to identify, because something wrong. The reason of wrong can be different. So that's why we need to use these 2 charts. Clear with this example? Why we need these 2 charts? Questions? Clear? Everybody? Okay. So how do you use the mean and range charts? First, we have to build this initial control limits, right? we want to get 20 to 25 samples. This example is not practical because we only have 5 samples. But if I give you 20 samples, we spend a whole class on just one example, right? But you know that in reality, you should get 20, 25, even larger. The larger the better, 100 samples you can get, right? Then compute the sample statistics. What does sample statistics mean? Such as the grand mean, such as the R bar, the mean of range. You calculate this. And next, establish the preliminary control limits, which you already guessed as lower control limits, upper control limits. And then we use these control charts, control limits, to monitor our performance. If any points be outside of the control limits, then we will search and correct assignable cause of variation. If it's nothing out of control limit, then we assume it's under control. Assume. Right? Resume the process and collect another set of observation to build the control limits. That means you can't rely on these control limits we have built now forever. Right? For example, after 1 month, okay, you hire another employer in this production line. That may change your performance. After 1 year, you get a new machine. That's totally changed the whole process. So the control charts, especially during the change, you have to rebuild the control charts to monitor your performance. So that's the purpose of the control charts. And plot the data to find what is under control, out of control. So next topic we'll talk about is the control charts for attributes. So mean charts and range charts are widely used in Dutch to control our quality, but they're not enough. They're not enough. So that's the reason we introduce P charts, which is to monitor the proportion of defects in a process. C charts used to monitor the number of defects per unit. You think about, right? We want to measure our performance by proportion. How many machines are broken? The percentage of machines are broken. Then we need to use the percentage instead of mean or range. Similarly, if we buy a second-hand car, we want to see how many dents in this car. That's the quality, right? How many dents? But you can't, the dent is lost, is always integer number, 1, 2, 3, 4. Well, it's lost the mean 2.5 dents. What does this mean? So that's the reason we have to introduce P charts and C charts. They're useful for some other situation to control the quality. So when the observation can be placed into 2 categories, good, bad, pass, fail, work, doesn't work, right? Then we can use this proportion charts, P charts. When the data consists of multiple samples of several observations each. So to build this proportion charts is pretty straightforward. And then we need first to calculate the sample proportion, P bar, is equal to the numerator is the total number of defectives. You can also think about the total number of failure, total number of doesn't work, right? Divided by the total number of observations. So you calculate the P bar. And after you get the P bar, the next step is to calculate the standard deviation of the proportion. So P bar number effective divided by number of observations. The next we calculate sigma hat P. P bar 1 minus P bar square roots. Then UCL P, the upper control limits for the proportion chart equal to P bar plus Z sigma P hat. Lower control limit go to P bar minus Z sigma hat P. Okay, it's clear? So that's the formula. You can first copy this formula, and then we have the example. Right? Once you understand the formula, it's pretty straightforward to build this P chart. Before the company like such as Seals, right, shipping the lawnmower to the dealers, like retailer store Seals, an inspector attempts to start each mower and the loads. Any that do not start as first try. The size, the sample size or lot size is 100 mowers, right? And average 4 dealer loads start 4%. So it's already tell you the P bar. But you can calculate 4 divided by 100, 4%. We want to use the P chart determine the 2 sigma control limits for this problem. 2 sigma. So Z equal to what? Yes, 2 sigma, right? So it's easy. For the lawnmower, I had this experience. The lawnmower doesn't work, right? When I first moved to North Carolina, I rent a house in Pinehurst. Before that, I always rent a condo. And then after 2 months, the landlord locked my door, said, "You didn't cut your grass for 2 months." I said, is that my responsibility? Please look at your contracts. That's your responsibility. So I have to rush to sales to purchase a lawnmower the first time. And then it doesn't work. I tried 10 times. I doubt myself because this first time I use lawnmower, that must be something wrong to start lawnmower. I go to YouTube, watch at least 10 videos how to start the lawnmower. I didn't see any trick. Well, maybe they're young, they're more powerful than me, but I try my best. Try another 100 times, doesn't work. So I came back to see the fixed problem. It's like sparkle plug some problem. Okay, I should go there first, but I think there's something wrong with me. So that's definitely the control of the lawnmower because it's wastes customer time. I will never purchase another lawnmower from sales from this bad experience. So how do you build that? Rinse? Question?
Yeah, so is the number of defects 4?
Yes.
Okay.
Yes. So it's 4 divided 100, you get P bar.
Okay.
Then you can go ahead to calculate sigma P. Sigma P is the thing you really calculate. No clue? What is the P bar? First question. What is the value of P bar? P bar 4%, 0.4 or 4%, right? 4 divided by 100. Once you get P bar, you can move to the second row to calculate sigma P hat. And yes. Okay. Don't forget the square root. Not clear? Sometimes. On the right track, calculate special results. Are you happy about your grade? Exam?
Pretty good. I'm all right with it considering where I felt like I was going in until I practiced that weekend.
I haven't started.
What's your
Were you happy with it? That's the question.
I'm happy about everyone. Even doesn't perform well.
Why is it doing that?
No, it's the sample size is 100.
In his 100, right?
Yeah, but N is the number of observations, so in this example, N equal to 100.
How did you get that? How did you get that? Square root first. Is that square root? Yep. How did you get that?
Calculate.
What?
Plug them in, 0.04 times.
Thank you.
Shouldn't be this number. Yes, this whole square root after divided by 100. So it's 0.04 times 0.96 divided by 100. Yeah, should be very close.
Yeah, Sometimes.
Square root.
So this will probably be the square root.
You want to keep like this
Point
two
zero
digits.
zero. Okay.
You want to keep 1.
1 minus 0.04. Yeah.
You got it?
I think so.
Yeah, that is not the end, right? We still didn't get the chance. Yeah, right. Okay, that's good
Upper
job.
and lower.
Yeah. Okay, that's question mark. 0.04 times. I think that number looks good, but just double check how you guys this one. Which one? Like points
What is that?
0.19 something.
Yeah.
Yeah, I rounded it up.
0.019, but you round up to what? 0.019 is not 0.012, but you can double check that.
0196.
0.0196.
Yeah, 0.019 something.
Good look in this society. Good look in
Good
this.
job. Okay, I have seen some students already guess the results. First, P bar. Okay, I don't need any volunteer. It's so straightforward, 4%. Right? And then let's calculate the standard deviation of the proportion, sigma SP. I need a volunteer to tell us how to do that. Anybody?
Take the 0.04
Uh-huh.
times 1 minus 0.04,
Uh-huh.
then divide by 100.
Good. What's the result you get? Means
Well,
0.0196, something like that. Right. And then last step is pretty straightforward. We just plug in this number into this formula. Upper control limit is P bar 0.04 times plus sigma. What is sigma? Oh, z value. Sorry, z value. What is z value? 2 times 0.0196. So you get 0.0792. Right. Similarly, lower control limit is 0.04 minus 2 times 0.0196. Should get 0.0008. Right. So, in the future, if you has another 100 molar, before you ship to dealer, you test that. If 8 lawnmower doesn't start, do you think it's out of control or under control? If 8 of 100 doesn't start. Yes, because the upper limit is about 7.9%. What about another scenario? You have 100 mowers. Every mower can start initially. Do you think it's under control or out of control? Zero. Zero defects. 100. Is under control?
No, it's out.
It's out of control because the lower bound has a tiny number, 0.08. It's out of control doesn't mean a bad thing. You really think, oh, why this time I'm so lucky? This 100 mowers, everybody works. Then you may find, okay, that's something we improve during our production, right? So out of control doesn't mean a bad thing. It can teach you a lesson to further improve your process. After you change the process, then maybe it's lower down the proportion of defects, right? Question, comments? Nothing? Okay, you guys have a nice weekend.